Hi, Professor. This is Gaoyuan Huang. I'm going to introduce my final project by going through the notebook. So the first part is exploratory data analysis. So first, import the data and transform the um, date column, and so I can plot it with matplotlib. Also because the training set doesn't need the date time, so I drop it here. And here is the describe of all the variables here. You can see the mean and standard deviation of the temperature and other variables. So here I plotted all the variables over the period of time, and you can see a very obvious seasonal trend of the temperature and also other variables as well. And here I plot a correlation plot for all the variables, and this is one for temperature, and it's not very the correlation is not very high. Yeah, not very high, but yeah, still it's a little. And then I'll pre-process the training set. Here I used a function from one of the link the professor gave, and this works well to transform the original dataset to the dataset that can be used in Keras. So I first get all the values from training set and normalize it using standard scalar to do z-score normalization, and then use this function to get the reframed dataset. Then I drop unused variables and split data into x and y. Now I did the same normalization for test set and reshape the training set and test set to fit the requirement of the Keras. And here is a shape of the final training set and test set. Now I'm doing the model building. So it's very interesting that the very first model I use becomes the best model in all my research here. So there's one LSTM layer with 50 number of units, no dropout, and the return sequences is false, so it returns one value and goes through one fully connected dense layer to output one value. And here is just the linear activation function. And the training result is 0.0461, and yeah, this is training history. You can see it's still going down. Maybe I can actually I tried training 300 epochs, but the result is not getting better in the public leaderboard. And here is the part I make the prediction. So we need to rescale back to the normal scale of the temperature, and substitute the temperature in the sample submission, and submit this. It's my final submission. Okay, thank you for listening, and